Welcome back, Python family, to the Python Made Easy series. This is class number 3 on Python functions. In this class, we'll deal with the nonlocal statement and we'll take a look at arguments. The nonlocal statement is similar in both form and role to global, which was covered in the previous class, class number 17 on functions in this series. Like global, nonlocal declares that a name will be changed in an enclosing scope. But it's an enclosing function scope, not the module or file scope. Unlike global, non-local names must already exist in the enclosing function scope when declared. They can't be created by first assignment in the nested def. Lookups are limited to the enclosing def. Okay, so let's dive right into an example. We have code here on the upper left-hand side. We have defined a tester function, and then inside of that, we've defined a nested function called nested. We say state equals start, our parameter in our enclosing function. But we make state non-local in our nested function. So now we get to change that inside the nested function. We get to change its value. And we do that right here by adding 1 to the value of state, so it becomes 2 after we call the parent, which will call its function nested. As is the case with factory functions, we call tester multiple times and get multiple copies of its state in memory, as we see in the output above. The object state in the enclosing scope is essentially attached to the nested function object returned. Each new call makes a distinct object state. That's why when we update one function state, it won't impact any of the others. So why do we care about nonlocal? Well, because unlike in regular functions, the nonlocal statement always allows multiple copies of changeable state to be retained in memory. It addresses simple state retention needs where classes are not warranted and globals do not apply. Let's see this in idle in debug mode. Okay, so here is our code from the previous slide. It's slightly different. I made a few modifications. I'll try to call them out. First of all, I got tired of seeing that none come back every time. Return happens automatically and it returns none. So it kept doing that. So I decided to put a bunch of asterisks in between the outputs. Probably it makes it easier to see as well. All right, so we want to go into debug mode so we see exactly what's happening here. This is fun because there's a lot going on, right, with these nested functions. So instead of whatever I called it before, now I have teams. Teams equals tester1. Teams, Knicks, Jets, Yankees. Sorry, guys. You can take the girl out of New York, but you can't take New York out of the girl. I apologize. We start at the top of the code. Def tester start. And now it's going to look for a caller. Jumps down to teams equals tester1. So we pass 1 for tester, and it should start its business, and it does. Line 2, start equals start. Next, it should go to the nested one, and it does. Now it goes down to return nested. This return, of course, is part of the tester function. Start 1, state 1, right? Start equals state, and it's set to 1. Step, but not for long. So then we print teams, Knicks. Boy, they're doing bad this year, guys, but I like them. Print label state. So we jump right here, right? From team Knicks, boom. Because, of course, we're passing teams, which is tester1. We pass it Knicks, which, of course, corresponds to label. So we go right to print label state. Right, we have Knicks for label, state 1. Step, 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 step. Prints out Knicks, step, step, step. We'll print out 1. Okay, new line. Okay, now what happens? State goes to 2, right? Bling. The next thing that should happen is should print out my asterisks. Step, boom, asterisks. And we run through it again. Print team Jets, right? Now, state is 2. Jets, prints that out, prints out 2. All right, same thing over and over again. Prints out Yankees. At least they're a team I can be proud of. So hopefully that made it easier to understand exactly what's going on here. But it's fascinating. We don't need a class to have state. Yay functions. Yay nested functions. Okay, my friends, time to look at parameters and arguments. So we have a function here called example. It has a parameter of c. So technically, the parameter is what gets defined in the header of the function. and the argument is what you pass in through the caller. So C here is the parameter, and Python is the argument that corresponds to C. So A now is equal to the value of C. The caller of the example function passes in an argument of string Python, like we said, which sets the value of C and by extension A. Function arguments are just another instance of Python assignments at work. Because references are implemented as pointers, all arguments are, in effect, passed by pointers. That is, arguments are never copied, but instead are pointers. So when example is returned to the function, it returns the value of A as dictated by our code with the value that we pass in as an argument through the caller of Python. Okay, let's take a look at this piece of code. We've defined a function named f, and it takes one parameter, a, and then in the body of the function we have a equals 99. So a gets assigned to the object passed in by the caller. In this case, that's b, which represents 88. But a lives only inside the called function. Changing a inside the function has no effect on the place where the function is called. It simply resets that local variable a to a completely different object. So b in the caller and a in the function have nothing to do with each other at all. Too idle to drum this home. Okay, let's take this in steps. I have 3 little snippets of code. We're going to look at the first one first. We have def f, and we pass it a equals 99. Then in the caller, we pass f 100. So what happens when we run this? None. It prints out none. Why? There is no return statement, so of course that implies return none. We never have a return to call a. So of course this doesn't do anything, and this doesn't do anything with respect to this particular function, right? It doesn't print out anything at all. It just prints out none. So let's see, in contrast, let's see example number 2. Okay, here we have the same thing, and then we have a equals 99 just like we do, but this time we return a. Now, when we pass in f100, that's great, that becomes a, but then a in the local scope is 99, and when we return a, that should print out 99. So let's see, we should have a none and a 99, none and a 99. Makes sense? If there was no a here, it would print out 100. But there is, so now who wins? Who wins is local, 99. Okay, good. Now we'll get back to exactly what we had in the example we just saw. Maybe it's becoming clear to you now. So we have f, a again, a equals 99, b equals 88. We call our function by passing it b, which is the same as saying f 88. Then we print b. Again, no caller. So the only thing that gets printed out here is 88. It has nothing to do with the function at all. B, 88, right? This calls but doesn't return. So we never get to see that. So this will print out 88, none, 99, 88. Does it make sense, guys? If not, leave me comments. I'm happy to help in any way I can. So in a function call, arguments must appear in this order. Any positional arguments, then keyword arguments, then the iterable form, and then the dict form. So arbitrary argument examples. The asterisk and the double asterisk are designed to support functions that take any number of arguments. So on the left-hand side, the star args. We've defined a function f that takes star args. When the function's called, Python collects all the positional arguments into a new tuple and assigns the variable args to that tuple. So you see here we call f and pass in no arguments. So it's not just one or more arguments, it's 0 or more arguments. Although it wouldn't do too much in this case, right? It just returns an empty tuple. But if we pass 1 to the function f, that prints out 1 comma, letting us know that it's a tuple with just one element in it. And then we can also pass 4 characters, showing that we can do as many as we'd like because it's star args. With the double star, it's similar, but it works for keyword arguments. It collects them into a new dictionary. So same thing here. We have g as our function, and we pass in double asterisk args. So now we know we're using keywords. So if we call just g with nothing, it's permissible, but it returns us an empty dictionary. Now, if we pass in key value pairs to g, it returns in kind, because all this does is print it out. So args and kwargs. keyword arguments. Okay, here's a slightly more advanced example, and this is using star args, so as many variables as we'd like. So this is intersecting an arbitrary number of sequences. So we define a function called intersect, we pass it star args, then we set up an empty list called res. For x in args 0, so this is going to evaluate the very first sequence that we choose to pass in. If x in res, continue. So we don't want duplicates. So we're saying if x is already in our list, so any element in that first sequence is in our list, just move on, just continue. For other in args 1 colon, so for each of the rest of the sequences, 2, number 2 through however many we have, we'll just loop and through, we're done. If x not in other, break. So if the element in our first sequence is not in this one, so the objects don't match, just move on. But if they do match, append x, that element, to our empty list or our list. It might not be empty at this point. And then when we're done, we'll simply print out our list. We passed hello, jello, and fellow to our function, and it found E, L, and O. Those are the 3 elements that we have in common. So we don't want any duplicates. We just want to know across these different sequences, which elements in these sequences do we have in common. All right, well, that's it for this class. Thanks again for joining us. And if this was helpful to you, maybe you'll consider helping me by doing the following: subscribing to the Yogi Coder page, liking this video, and sharing it so that I can help other folks. All right, guys, see you in the next one.